Thank you so much again for doing this. I'm very excited. This is probably happens to you all the time. How do you feel about knowing that you'll get bombarded with questions every time you're doing an interview?
I love it. This is I just enjoy answering questions. That's the basis of my podcast, Ask a Spaceman, is where people ask me questions. For years, I hosted a live radio show where people would call in or drop messages asking me questions, and I would answer them live. I would have a planetarium show once at one point in my career where I just stood at the bottom of the theater and there was an operator running the computer in the back. People would just ask me questions. The operator would bring up visuals and then I would answer them. I love it, actually. I live for it.
It's amazing. It seems that, because before sending the email to you, I've been completely immersed with all of the content that you've been producing on YouTube and all of your different interviews. And, I'm especially interested in the intersection between art and science, but I guess we'll talk about this a bit later. But before moving further, I'm really interested to explore a bit your passion towards the whole field that you are involved in, because from all sorts of content that I've been seeing involving you, it seems that you always have such strong passion and it's always interesting for you and you're really enjoying what you do. So walk me through that. How did this develop for you?
Yeah, the easy thing is I love it. I'm fascinated by it. I personally find all this interesting, even areas outside of my own particular research. When I learn about it, I think it's really cool and interesting and fascinating. And so when I speak with enthusiasm, I'm speaking from the heart. I'm speaking from myself. I think this is all super cool and I love to share it and I love to talk about it and I love to teach. I love to educate and I love to get people to understand and see the universe the same way I do. I've always been fascinated by science. I remember ever since I was a kid reading science books, begging my parents for more, just trying to get my hands on as many science books as possible. I loved everything about dinosaurs and paleontology and astronomy and biology and geology and physics and just all the things I was constantly reading. But as I was becoming a teenager, I never even realized that becoming a scientist was for me. I always thought and I always assumed that science was a thing done by much smarter people, by different people, and certainly not me. I was a nerd, however, so I went into college as a computer science major, and I wanted to work in a science adjacent field. I wanted to program satellites for NASA. I wanted to work with scientists, but it never even occurred to me that I could be a scientist. And then it wasn't until my third year of college, I was taking an astronomy course as an elective, as an optional course. I thought it'd be really fun. I'd always loved these topics. And so now I thought it'd be fun to learn about it a little bit more rigorously. Within a couple of weeks, the professor pulled me aside and said, look, you seem really interested in this. You're doing great in the class. You have an aptitude for this. You can be a physics major, right? If you want to be. I was like, wait, what? He said, yeah, like you can be a physicist. This can be for you. My head exploded. I never realized that this was an option. It all clicked within a week. I changed majors to physics and I've never looked back.
Wow. I mean, you've mentioned that you've been fascinated by so many different things during your childhood. Do you remember a specific moment that it clicked in your head that you are fascinated specifically by, astrophysics and cosmos and all of that? Was there a specific moment where you got your mind blown by something?
Yeah, there actually wasn't a specific moment that I narrowed down into this field. It was a slow and gradual evolution. In undergrad, I did some research on quantum field theory. I published my first paper in quantum field theory, and I just wanted to be a physicist. That's what I wanted to be. That's where I wanted to take my physics degree, was in research in academia. And so I applied to a bunch of graduate schools. I got into one. I went in knowing I wanted to be a physicist, but not knowing in what direction, because so many different fields interested me. I talked to many potential advisors, some in astronomy, some in cosmology, some in high energy physics, some researching chaos theory, some studying biophysics and the relationship between physics and biology. I found all of them fascinating, and I just kept talking with the potential mentors, talking with the faculty, having conversations. And then over one conversation with a faculty member at my graduate school, which was the University of Illinois at Urbana-Champaign, who became my advisor, Paul Ricker. We were chatting, and there was this interesting project idea that he was cooking up with another faculty member named Ben Wandelt about the relationship, a potential relationship between dark matter and dark energy, and how this idea had been proposed, but we needed to dig into more with simulation work and with computer work. And this had always been a skill set of mine, of doing simulations, of doing work with the computer. The project seemed interesting to me, and that specific project seemed interesting to me. And so I dug in and I loved it. And then I just kept going.
Amazing. Amazing. I mean, it's so interesting to see the different fields that you've been involved in, and, you know, how this enrich your, you know, your interest in the whole field. So as far as I know, because I've read your bio and, you know, again, I've been really researching you. You're currently, and correct me if I'm wrong, you're working on exploring the empty spaces in the cosmos and in the universe and so on. Can you walk me through that? Because I'm so interested in the process of people like you, professionals in this area, in their, you know, day-to-day routines, and how they you know, how they extract the information that we at some point receive as the end user.
Yeah, exactly. So I'm absolutely fascinated by these objects in the universe called cosmic voids. These are the largest empty regions in the universe. The smallest ones are 20 million light years across on a side. They actually fill up the volume of the universe. Anywhere between 80 and 90% of the volume of the universe is in a void, and the voids contain almost absolutely nothing. I got interested in voids after my PhD. I spent 6 years working on my PhD, and shortly before graduation, I was searching around, and one of the people I had worked with early in my graduate career, Ben Wandelt, who had suggested this idea that I worked on with my advisor about interacting dark matter and dark energy. Since that, we had worked together for about a year, and then he left for the University of Paris. And I stayed in touch with him, and I mentioned I was graduating, and he said, "Hey, I have a position open. Would you be interested?" And I said, yes. And so I didn't even have to apply to a whole bunch of jobs. I got, you know, just straight tracked to working with Ben. Moved to Paris. We started working on voids together. He had this interesting idea, and I took it, and we wrote a bunch of papers. And now the work is being largely sustained by a large number of collaborators, like Lice Pisani, Nico Haumaus. Ben is still active. I'm still active. There are a number of people that are working on this topic. And the basic idea is to look out at the universe, which we do all the time. We have galaxy surveys. We're mapping large portions of the universe, the locations of galaxies in the universe, and paying attention to where the galaxies aren't, and developing tools and methods for mapping these regions, for measuring them, for locating them in our surveys. And then we have, once we have these list of voids, their locations, their extents, we can do all sorts of things. One is we can examine voids as an interesting facet of nature. This is a thing found in nature that we can study. They have interesting properties. And so there's one line of research that is all about just investigating the nature of voids at a fundamental level. There's another avenue of void research, which is the properties of voids, like the number of voids, their sizes, how they evolve with time, is intimately connected to burning questions that we have in cosmology, like the nature of dark matter and the nature of dark energy, the history and the future of the universe. All that information is contained in the properties of the voids, which is a direction that cosmologists have not really looked in previous to this research. And so that aim is to study the voids, extract their properties, and then connect those properties to things like the nature of dark matter and dark energy.
Wow. Wow. This sounds so interesting. Like, is there a specific, and I know this is a very simplistic way to ask this question, but in general, how are the voids being formed? Because we know about entropy, we know about the physical, the connection between particles in cosmos and so on and so forth. Like, is the formation of voids, just something that is, something that happens, just a coincidence of different processes? So if there is there like a specific reason to for them to be formed?
Yeah, so the voids don't just appear, they are a consequence of natural processes that happen in the universe, which is what allows us to connect them to fundamental properties of the universe. What we find at the very largest scales, when we zoom out, when we do our biggest surveys, we're looking at such enormous volumes that galaxies, entire galaxies, are just tiny, tiny points of light. When we're looking at that kind of scale, this is where we see a structure appear. We call it the cosmic web. The cosmic web is made of dense nodes, clusters of galaxies, long, thin filaments, like highways of galaxies. We see these broad walls made of galaxies. And then in between all those structures are the cosmic voids. And so this cosmic web has evolved over the past 13 billion years. 13 billion years ago, our universe was much more uniform, much more even. The density of matter throughout the universe was pretty much the same everywhere, but there were tiny little differences. And those tiny little random differences eventually grew up, because if you have a tiny little difference with just a little bit more energy, a little random pocket of the universe with a little bit more density, it will have a little bit more gravity. And that slightly stronger gravity will cause it to pull on its surroundings. It will accumulate matter, which gives it even more density, which gives it even more gravity, which allows it to pull even further away. And so we see over hundreds of millions of years this cosmic web emerging, where matter groups itself together from small to big. The galaxies emerge, groups emerge, clusters emerge, and then all that matter has to come from somewhere, and it comes from the rest of the universe. And so matter gets evacuated from the voids.
Wow. That's a whole another aspect that, I haven't personally kept attention on. For you, what's the most exciting resultant outcome that you can generate from your research on this specific matter? Like, what's the most interesting thing that you think you can get extract from it?
One of the most fascinating things that we've discovered about cosmic voids is that they all share common properties. And in fact, all voids are pretty much the same throughout the universe. They have certain universal properties. There are small voids. There are big voids. There are voids that have these dense walls surrounding them, almost boxing them in. And then there are voids that just smoothly transition into populations of galaxies. And at first glance, you look at all these voids with all these different shapes and sizes and properties. But we were able to discover some very universal features among voids, and that if you actually take a small void and you find a random small void, and if you were to stretch it out, you would actually end up smoothing things out and you would make it look like a big void. And if you were to take a big void and scrunch it down, you would actually recover the properties of a small void. So we found this universal connection between all the voids. We actually learned that voids are fractal in a sense, that they can be rescaled and maintain their properties. And this universal behavior of voids has allowed us to unlock so much knowledge about them, because it means we can do a survey of the universe, we can gather a lot of voids, and we can apply those properties throughout the universe.
Wow. Probably a common response to most of the things you say, but still. Wow. I mean, it's a part of that. Is there like a still aspect in general when it comes to astrophysics and it's darkest secrets, let's say, that you are very fascinated by and completely mind blown? Like, is there an aspect that you still approach more as a outsider rather than a professional?
Yeah, absolutely. Because the day job is filled with just work, and where you just you're worried about the details of this survey. You're trying to apply this correction factor. You're trying to create just the right statistical analysis. You're trying to find important relationships. You're trying, et cetera, et cetera, et cetera. And so the day job is just filled with work. But when I pause the day job, and, I put the pencil down, I scooch the laptop back, I step away from the chalkboard. And when I realize and take a breath and really digest what I am grappling with here, what my colleagues are writing about, when I read a new paper, like what this is about, we're talking about structures that are 100 million light years across. We're talking about structures that took 13 billion years to arise. We're talking about the entire fate of the universe. And the fact that we can actually wrestle with these concepts, we can actually dig in, that we have the tools to do it. We have the telescopes to scan deep into the early history of the universe. We have the computational complexity that we can actually simulate the evolution of the universe at large scales, that I can write down an equation on the chalkboard and we can talk about these universal properties of voids. And I'm talking about objects that are beyond my imagination in both space and time. I can't hold the concept of a cosmic void or the cosmic web, the large scale structure of the universe. I can't hold it in my mind. I can look at a picture of it. I can write down an equation that describes it, but I can't actually understand at a fundamental level the enormity. And when that strikes me, when those moments strike me, I relish it, because that's what gets me excited. Like, wow, I'm actually studying the universe, and not many people get to say that.
Yeah, that's so amazing. That's so amazing indeed. Like, let's say you could, you could research or find the secret of some of the, most essential and discoverable principles of the universe. What would it be for you? Like, what would you like to understand or see or grasp your mind on?
Yes, and there are all sorts of amazing cosmological questions that all connect together. So, for example, 95% of the universe is of a form unknown to us. Wow. We have learned over the past few decades that the vast majority of the universe, 95% of the universe, is made of one of two things, either dark matter or dark energy. Wow. Both of these substances, we do not understand what they are. We can see the effects these substances are having on the rest of the universe, but we don't know what the identities of these substances are. And so that's a major burning question. It turns out all these centuries of effort in the field of physics, and we've uncovered fundamental forces in the zoo of subatomic particles. Everything we know and we understand amounts to less than 5% of the cosmos, which is frustrating, I'll admit, but also exciting because it means, our horizons are just beginning to open up. And related to those questions are the questions about the very earliest moments of the Big Bang. We can push our theories back to the first few seconds of the history of the universe, and we've had great success in that. And that's amazing that we can do that. Like, we shouldn't even be able to do that, but somehow we're able to. But the earliest moments of the universe are still beyond our grasp. They're still beyond our understanding. We hope that by understanding dark matter and dark energy, we might be able to leverage that to get some handle on the earliest moments of the universe and vice versa. But right now, these areas of our universe, the earliest moment, the largest scales, are beyond our current ability to reckon or understand, which is just... it's beautiful. It's exciting. And yeah, it's frustrating, but also it helps remind me that whatever advances I make, whatever collaborations I work in, whatever we learn, we are one part in a chain of a continuous series of scientific understanding, that the final answers won't come with me and my generation. That's not how it works, because every time you answer a question, you'll get a dozen more to replace it. And so we're part of this continuous chain of unfolding, this continuous progression of expansion of our knowledge and how we learn more about the universe. And that part is very beautiful and humbling to me, that there are centuries behind me that have led to our current present understanding, and then I get to participate in it. I get to add to that tower of intellect, and then there are hopefully centuries after me that will take what I've learned, what my colleagues have learned, and apply that to new understanding of the universe.
That's such a good mental approach to this process, because I've always I also wanted to ask you, like, because for me it's very frustrating that I know I wouldn't be able to understand the big questions that I'm interested in. This genuinely frustrates me. And I'm very curious to hear, your outlook on that, because it's an emotion that is very specific. And I'm curious how people battle with it, especially when you've dedicated such a big portion of your life to it.
Yeah. And it's to realize that you are one part in a continuous series, that our experience in this generation of scientists, we are one chapter in a much larger story, and that there is a legacy there, not in having the final answer, but in adding to the wealth of human knowledge, in contributing to that there is a legacy there, that hopefully my papers will be read and the papers of my colleagues will be read and used. And even if I'm not cited in 100 years or even 50 years or even right now, that's okay, because as long as someone takes something that I was able to contribute, learns from it, and then builds from there, that is part of the larger story. And being a part of that story is a true privilege and a true honor and a true joy.
Amazing. Yeah, that's such a beautiful way to look onto it, I guess. Okay, so I've always want to ask professionals such as yourself, considering that you have such a deeper knowledge in the team, about two main questions that always baffle me and I can't perceive, but I'm always interested to see how you people with deeper knowledge perceive. So
let's do it.
What was it before the Big Bang? Like, what is nothing? I can't even visualize it, and I'm interested to hear how your mind visualizes it.
The truth is, my mind does not visualize it. this is a major philosophical question. This goes beyond science, because we can envision the universe, the Big Bang, the singularity, the earliest moments of the cosmos. We can envision maybe there was something before that that triggered the formation of our universe, the triggering of the Big Bang. But then you're just pushing the clock back. You say, well, okay, if that's how our universe came to be, well, then how did that thing come to be? And then how did the thing before that come to be? And then you ultimately arrive at the question where we're using physics to understand all this. We're writing down physical laws. Well, okay, why are there physical laws instead of no physical laws?
Yes.
And then you go even further. You say, well, why is there the bare fact of existence itself rather than not existence? And this is a long-standing philosophical question that I don't think I'm going to arrive at an answer yet anytime soon. But in that is beauty, it's wonder, it's mystery. I don't know. I can't envision. It's perfectly possible. It's perfectly possible when we're talking about the earliest moments of the Big Bang, when we're talking about when the universe is so small, our basic concepts of time and space may not even apply. We're so used to these concepts of spatial extent and temporal duration, and that these are measurable quantities and that these are quantifiable quantities. When we get down to incredibly small scales, that conception breaks down. And so I openly wonder if something like the beginning of the universe, if that is beyond our ability to comprehend, because ultimately we are brains, we are human beings, we have evolved in a 3 spatial dimension universe, we have evolved with this sense of past and present and future, and that it might be impossible for us to think beyond those bounds or not. Maybe it is possible to think beyond the bounds of space and time. Maybe it is possible to think new ways. We are very imaginative after all. And so I wonder if, aliens came to visit and they had to crack the code of what happens at the earliest moments of the Big Bang. And I wonder if they would be able to explain it to us in a way that we would understand. Wow. And then that provides an opportunity to start, working that mental muscle. Like, wait a minute, is there a way to envision this that goes beyond our current framing of understanding, not just our current physics, but our current way of how we construct physics? Is there a different way to approach this? And then it gets deeply philosophical from there and way above my pay grade. I'm just a poor country astrophysicist trying to understand cosmic voids, but that is something wonderful to think about. That's what I think about when I'm late at night on a warm evening looking up at the stars. That's where my mind starts to go.
Yeah, likewise. And the other concept, and probably it's very similar in nature, but still I would be interested to hear your outlook. Singularity. Like, I can't envision what does it mean to, the physical walls to not be active at a certain space. So yeah, can you talk about this a bit?
Absolutely. And this is exactly what I was getting at. When you crunch things down below a certain scale, we are not sure if space and time make sense anymore. We know that our physical theories break down. What we call a singularity is a point of infinite density, where you take all the matter, say in the universe, and compress it down in its earliest moments, you get a point of infinite density. When you want to make a black hole, you take a bunch of matter and you compress it down so that gravity takes over. And then once gravity takes over, it just cascades and it pulls everything down into an infinitely tiny point. We know that's not the case. Infinitely tiny points don't actually make sense. It's a sign that our theories of physics are breaking down, that we do not have a complete understanding of these kinds of entities in our universe. And there are places we can point to where our physics is breaking down. If you point at a black hole, we can say with confidence that we do not fully understand black holes. If you point back in time to the Big Bang, we can say with confidence that our theories of physics are breaking down. We do not fully understand the Big Bang. And that's great because that is the edge of knowledge and that is the opportunity to learn.
That's a very good way to approach it. Can be like considering all the knowledge that you have about the universe and the way things are in its essence. I'm curious, how does this knowledge affect your daily life? You know, your ordinary life as a human being. Because I know that for myself, even grasping very basic and very simple concepts about the universe very much changed outlook on things that are just in front of you in your daily life. So I'm curious, how is this aspect for you?
Absolutely. There's this talk of that astronauts have, you know, they go to this space station, they spend a few months up there and they come back with something called the overview effect, where you get to see the Earth for what it really is, which is a small, special, fragile world with no national boundaries, just continents and oceans and clouds. And it's beautiful. And once you can see the Earth from that perspective, when you see how small it is, how tiny we are compared to this vast ocean of night that surrounds us, you come back with a different sense of how to approach humanity, how to approach relationships, how to approach conflicts. To me, astronauts do not have a monopoly on the overview effect. That when you talk to astronomers, when you talk to cosmologists and other fields too, when you talk to archaeologists, paleontologists, geologists, any profession where you get to zoom out either in space or time, where you can dig deep into the past, or you can zoom out and you can see the vast cosmic scales, I believe that there's an overview effect there too, where you see, we routinely talk about in astronomy, like, oh yeah, so that supernova went off. Okay, that supernova, if it was placed in our solar system, would literally obliterate the Earth. Right? Like the energies involved, the scales involved, what the universe is truly capable of, and how long the universe has existed, and the transformative epochs it has experienced already, and then how much into the future our universe still has to go. These are humbling facts. These are humbling realizations. These put things into perspective. And so, no, I don't apply my knowledge of cosmic voids on a practical day-to-day level. You know, it doesn't help me, with my relationship with my kids, or how to, earn more money, or investment advice. No, it's none of that. But it does offer a layer. It allows me an opportunity to pause, to remember the true scale of the universe, to realize just how fragile and special the world is, and to cherish what I do have. The universe is vast and cold and uncaring and all that, but I'm special. There aren't a lot of human beings in the universe. There aren't a lot of Paul Sutters in the universe. There aren't a lot of my wife or my kids. There aren't a lot of that in the universe. So this is what matters. This does matter. This is important. And maintaining this and celebrating it and existing in it are also important.
Amazing. That's such a good way to put it. So, I've found my interest in astrophysics and in space since I'm coming from a music background. And what connected me with this topic was Brian Greene and his interconnection between universe and art, and all of this. And what really fascinated me with you is your connection with music and with art as well. I would love to hear your breakdown in terms of what does it mean for you, this connection between this knowledge and the essence of who we are in the universe, and how art and music and everything else is sort of a direct representation of who we are, I guess.
Yeah, I like to think that scientists and artists are far less different than they are made out to be. Mm-hmm. We may have different tools. We may have different approaches to our work. Scientists use a lot of mathematics and logic and rationality and empiricism and all these philosophical tools to approach our investigation of this mysterious universe that we find ourselves in. But artists, musicians, dancers, they're also exploring this mysterious universe that we find ourselves in. They may be focusing on different aspects. I'm trying to go out and measure cosmic voids, and maybe a dancer or musician is trying to explore some aspect of the human condition, but that's still an exploration. We are all humans. We have arrived into consciousness somehow in a universe that is complex and mysterious that we are trying to understand. I see us all as co-explorers, co-curiosity seekers on this journey. And so I don't see science and art as at odds. I see them as complementary, where when I see a piece of art and it strikes me and it makes me contemplate, or I appreciate the beauty, that is an exploration of our world. When I see a dance, my wife is a modern dance choreographer, and her job is exploring the universe around us and expressing that exploration through human movement. And so when you see a dance performance, you are also exploring the universe around us. And so I try to work with artists as much as possible, especially when it comes to science communication, because there is so much to share and there is so much that we have in common.
True. That's very true. What is art for you? How would you explain it and describe it from the perspective of, the large scale and essence of the universe? Because, it's very natural, obviously, to us, but I often think, from an objective point of view, this is still a way for us to represent ourselves and to connect to who we are. But it's, the more time it passes, the more of a phenomenon I think it is, So yeah, I'll be curious to hear your thoughts on that.
The universe is mysterious, and the universe is complex and interesting, and it is difficult to share a lot of scientific research output with the public. I do believe that scientists have an obligation to share their work with the public, mostly because the public are the ones who are paying for scientific research. Almost all scientific research, fundamental scientific research in most countries is publicly funded. And so I believe that the public, they're the ones who paid for it. They deserve to know what they're getting, what they paid for, and they get to decide if they get their money's worth. And I do believe that there is a sort of social contract between scientists and the public, and we do owe it to them. Communicating science is very challenging. I do not believe in dumbing down. I believe that the people I'm speaking with are smart and intelligent and capable and curious. Their minds are probably filled with other things like their day-to-day job, their lives, trying to survive in the world. Honestly, most of my waking hours are spent just trying to navigate the world and then applying my knowledge to my day job. If I had a different day job, I would be spending most of my time thinking about that. So of course, I don't assume that people are going to be thinking about cosmology or the Big Bang. And so I believe it's my job as a science communicator and a science educator to get people to think about it and to speak about it in a way that resonates with them, in a way that they can appreciate. The facts don't necessarily matter. Let me qualify that statement. I'm not, the facts do matter, but the particular details and the nuances, that's not my primary goal when I'm communicating science. My primary goal is to get someone to appreciate and understand and like science so that they start thinking about it more, they start reading about it more, and they start understanding it more. Then the facts can come and all the nuances. But I just want people to resonate with science. I want people to connect with science because I do believe that science is an incredibly powerful tool set for exploring the universe. Mm-hmm. We have learned a lot through the methods of science, and I want to share that method and the joy of discovery. And I'm willing to do it any way I can.
Amazing. You are very good at this role of being a science communicator and this sort of essential information reaching more audiences and more people and so on. Do you have a specific way? I'm very curious to when you meet a random person or someone that you need to connect with and to showcase the significance of science to. How do you do that? When you are presented with a rather neutral audience, but you need to showcase the fascination of what you are going to present. Is there a specific concept that you do, or?
I just let my guard down.
Mm-hmm.
I share. I'm naturally excited about all this science stuff and fascinated by it and curious about it. And I love sharing it. And so I remind myself to not be afraid to be vulnerable, to allow people to see how much I love this and what I find fascinating, and allow that enthusiasm to be infectious and to connect on that very fundamental human level, that when people start asking me questions, that means they're curious. That means they want to know. That means they want their question to be answered. And that's a very privileged position to be in when someone comes to you, hey, you're an expert. I'm going to start asking you questions. That means they want to know. That means they want to be challenged. That means they want to learn. And if I can participate in that journey, that is a very beautiful, precious thing. And I never want to waste it. And I try not to waste it by helping them, by focusing on helping them in their journey of curiosity.
Amazing. Fantastic. Thank you so much, Paul. Thank you for your openness. Thank you for committing to the conversation. It was massive pleasure, honestly. I had so much fun. And thank you for answering my questions, honestly. I'm very much
thank you so much for having me on your show. I really appreciate it.